Hi, my name is Daniel Ye. I'd like to share with you about our work on composer classification. Our problem statement is to classify unseen piano sheet music, audio or MIDI, by composer based on its compositional style. In this work, we consider a 9-way classification task among well-known classical composers. This paper has 3 main contributions, 2 of which we will cover in this short talk. Let's start with a brief overview of previous work in composer style classification. At ISMIR 2020, we proposed a way to perform composer classification of sheet music images using language model pre-training. During training, we extract a bootleg score from the sheet music, convert the bootleg score into a sequence of 64-bit integers, which serve as musical words, train a language model on a large set of unlabeled data, then fine-tune the model on a small set of labeled data. At test time, we convert the sheet music into a sequence of words as before, and then classify the sentence using the fine-tune classifier. This approach was proposed last year and is representative of the state-of-the-art in composer-style classification. Now, we will introduce the first of our 3 contributions, which is to propose several musically informed data augmentation strategies. The key idea is to generate musically plausible variations of existing data. One obvious strategy is to consider key changes, which correspond to shifting the bootleg score up or down. We also consider several augmentation strategies based on randomly removing notes with some probability. We explored 3 variations of this: dropping individual note heads, dropping the left or right hand, or dropping an entire bootleg score column. This figure shows the performance of several models without data augmentation on the sheet music composer classification task. The different colors show different pre-training conditions. We can see that pre-training substantially improves the performance of all models. Now let's look at the effect of the proposed data augmentation strategies. This shows the improvement in model performance when we add musically informed data augmentation. We can see that augmentation has an even bigger effect than pre-training on all IMSOP piano scores. Furthermore, using both pre-training and data augmentation results in huge performance improvements. For example, when adding data augmentation to the IMSOP pre-trained GPT-2 model, performance increases from 0.67 F1 to 0.95 F1. The second of our 3 contributions is to demonstrate the effectiveness of cross-modal transfer learning. For these experiments, we take our classification model trained on sheet music images and use it to classify audio and MIDI queries. Audio queries are first pre-processed with the onsets and frames automatic music transcription system, and MIDI data can be converted into a bootleg score using the conventions of piano sheet music. This figure shows a cross-modal transfer learning results with the same 4 model architectures and 6 different query directions. The color bars indicate performance on MIDI queries, and the black horizontal lines indicate performance on audio queries. We can see that transfer learning is highly effective across modalities, far surpassing random guessing. The third contribution of this work is to show the effectiveness of our trained models in a one-shot learning context. To hear more about this, please attend our long oral presentation or our poster session.